Hello, welcome. This is a brief talk about the LibreSOC Gigabit router ASIC. It's an entirely Libre licensed ASIC being developed as a collaboration, and it will have Gigabit Ethernet ports to USB 2 and full Libre licensed firmware to the bedrock. Why would you want a Libre Gigabit router in the first place? Well, firstly, most router ASICs are proprietary. You can't inspect them, and yet we rely on them. Everybody has a router in their homes if they have internet access. You get persistent GPL violations in those products, and you also get lockdowns. The person owning their product is not permitted to see what the firmware is or to replace it or upgrade it. The actual hardware could contain unknown spying backdoor silicon, and nobody will be able to tell. So consequently, if you have the full HDL and the firmware source code to the bedrock, it means it's 100% auditable. Who is involved in this project? Myself, Luke Layton, lead developer of LibreSOC. Jacob Liflerche, also a member of LibreSOC, senior developer. Jean-Paul Chaput from Libre-SOC.fr, just part of Sorbonne University. He's the developer of the Coriolis 2 VLSI toolchain, who will be handling the creation of the layout and improving the actual VLSI tool itself if it needs to be able to handle the size and scale of the SoC that we're developing. And Staf Verhagen of Chips for Makers, Belgium, who is developer of the FlexLib cell libraries. He will be doing the SRAM for us, the SRAM in the caches, etc., etc., register file, etc., etc., and in the gigabit packet frame, we need some SRAM there dual ported. So what is it we're doing? We'll be doing creating a vector processor based on the power instruction set. This is the LibreSOC core with draft SVCP64 Cray style vectors, and we'll be also adding again draft packet processing instructions to reduce the load on the actual main core, so that if it does need to do any packet processing, it does so efficiently. Jumping out of order, about that, we will be adding a special DMA engine which will independently handle fast transfers between the Ethernet ports. So as the packets come in, the processor can do a minimum of analysis of where the packet is supposed to go, and then hand off to the DMA engine to say, you deal with it, sending it on to out of this port. So there will be 5 gigabit Ethernet ports, which is standard for routers. There will be 2 USB ports. Now these will be digital using USB ULPI and ultra low pin count digital interface. Will be standard GPO, I2C, quad SPI, etc., that you'd normally expect on any ASIC to be able to boot it up, and handle its own firmware. Also, Sorbonne University LRP6.5 is going to help us create an analog PLL. The last chip that they did for us, helped us with, it was a proprietary toolchain, but this time we want to have a go at doing an analog PLL that's entirely Libre licensed. We were just doing a huge amount of simulations and FPGA testing. All of this will be source code entirely online as it's developed. We know we'll release it when it's ready and finished. It will be done, release handle as a Libre project will be done in real time. Finally, we put it all together, just as we did with the 180 nanometer ASIC. We'll put in MPW shuttle runs. When we get those back, they actual tested, and we'll provide a full report and publish it. Everything will be entirely Libre licensed. The only condition on that is that it is best as we comply with Foundry NGAs, which may prevent us from releasing the full files. But we have a procedure there which we followed and explained in the with the previous ASIC that we did. So, yeah, thank you very much. Any questions? Links are provided here to where you can find out more details. Thank you.